No problems with that homework? All easy peasy for that? Yep. Okay, good. Let's continue. Please write this down. We're going to do the vector triangle next. You know triangle? Okay. Continue. So vectors can be added together by using what we call a vector triangle. So let's say we have two vectors, A and B, and we want to work out, to calculate the sum of the vectors, which we call the resultant vector. So you want to note that word. If you add two vectors together to get an answer, this is called the resultant vector, because it's the result. So please note this word, resultant vector. Yep. Which I call OR. And you can do this as shown below. So let me show you how to add vectors together. So if you have two vectors A and B, what you do is you put the tail of B at the head of A. And the answer, A plus B, will just be from the tail of A to the head of B. So for example, let's say I have two vectors. Let's say this is vector A and this is vector B. It's important that you understand that this vector here is also B, because it points east, yeah, and it's the same length. So it's the same vector, true? Same as this. Same as this. So what we can do is we can take the B and move it here to be with the A. Now that the tail of B is at the head of A, we add them together like this, and this here is the vector OR, which is A plus B. So this is how we can add vectors. It's only one way to add vectors. There are other ways, but this is what we use in this course, the vector triangle. There's other things using parallelograms as well. So if you can draw this, please, this is called the vector triangle for adding vectors together. Does anybody know the name of the other way? Has anybody used the parallelogram method? You know other way, yeah? What does it look like? Yeah, that's called parallelogram. We use the triangle. Okay, have you got that? Can I continue? Yep. So, to add two vectors, you must put the tail of one at the head of the other. Okay. You can multiply a vector by a scalar. When a vector is multiplied by a number, what do you think happens? So let's say, for example, I have the vector A, and I want to multiply it by 2 to make 2A. What happens to the vector? Yeah, it doubles in length, twice as long. What about half A? Shrinks minus A. Backwards, yeah. So, such as 2, as an example, it doubles. If I use a half, it halves. And if I use minus 1, it's flipped around. It points the other way. Yeah. Okay, so, of course we can add, subtract, multiply and divide scalars. You all know how to do 2 plus 2, 2 minus 2, 2 multiply 2, 2 divide 2. There's no problem there. With vectors, we can multiply or divide by a scalar. We can add or subtract vectors by using the vector triangle. But we cannot multiply vectors. We can, but we can't in this physics class. So we don't multiply vectors in physics. And we can never divide a vector by a vector. Even in other physics classes that are more advanced, you can never divide vectors. You can't do vector A divide vector B. Not really possible. So, that's just summarizing what we've done so far. Let's have a look at an example. Can you write this example down? And then we'll do it together. So we have two vectors, A, which is 5 kilometers east, and B, which is 5 kilometers per hour north. Okay, let me know when you're ready and we'll work on these together then. Okay, shall we start them now, or you need a little bit more time? More time? Okay. Yeah. Okay, let's have a start anyways. Let's have a look here. So we have two vectors. A is 5 kilometers east and B is 5 kilometers per hour north. First, let's draw these vectors. So A is 5 kilometers east. Let me draw that. So this is A. And then let me draw B, 5 kilometers per hour north. So this is B. So that's the first part. That's okay, yeah? Right. Next part. That's part A. Part B. Can these vectors be added? No. Why not? Very good. The answer is no, because the dimension of A is a length, and then the dimension of the B vector's magnitude is a length per time. So we can't add these together. We're not allowed to. Okay. C. T is 2 hours. What's the dimension of TB? So what is the dimension of TB? And T is in hours. Okay, so what's the dimension of T? Time. And the dimension of B? Length per time. So what are we left with? Length. Yeah. Okay. Let's draw TB. So what happens if we multiply B by 2 hours? If we multiply it by 2? It'll be 10. It'll be twice as long. Yeah. So let me draw that here. That will look like this now. This is TB. Okay, E. Draw A plus TB. So we need to put the A here. And then we can add them together. So let me just copy that here. This is TB. this is A, and this here is the result. By the way, if you did it the other way, if you did A first and TB second, you still get the same answer. It doesn't matter. Okay, and then finally F. What does this OR represent? So what exactly is this OR? So think about what A is, think about what B is, think about what TB is, and tell me who can describe what the OR is. Yeah. Velocity? Nearly, not quite. It's a type of displacement. But give me the story. What happened here? Anyone want to try and describe what happened? Okay, I'll describe what happened. So, A is 5 kilometers east, yes? And B is 5 kilometers per hour north. So this is as you said, a velocity. But we multiplied this by 2 hours. So what has it become? It became a length. It became not quite distance, the other one, displacement, yeah. So if you think about it, because we added it onto the A, what's happening in the story is somebody was 5 kilometers to the east. Then they headed north at 5 kilometers per hour for 2 hours. So it's like they started here and walked north for 2 hours and ended here. So like this is me here, this is someone else here. She started here and then traveled north for 2 hours. So we could describe it as a person at A then walks for T time with velocity B. Yeah, this is how you could put a story to what you did. What word are you checking? Velocity? Okay, go ahead. I gave you the definition, but go check it. Velocity. Good. What's it in Chinese? Correct. Okay. Continuing. Can I go to the next example? Yep. Okay. Here's another one. I think it's a bit too much English to write it all down. I think we'll just do this one together as we read it. Okay. So a man walks 5 steps north, 5 steps west, 1 step east, and then 1 step south. This took 9 seconds. Now I'll do this one with you, but I would like you to try to do each part before I show you. So just try the first part A and tell me what answer you get. And the units we're using is steps. So the answer will be steps per second. Okay, I think that should be enough time. So, what do we get for part A? Yeah, that was 12 steps over 9 seconds, which is 1.33 steps per second. Do you all get that? Yeah, good. Okay, now the next is to draw the 4 velocity vectors. Let's do that one together. So, his first one was 5 steps north. So this could be, for example, 5 steps north. The next one was 5 steps west, so that's this one here. But to make life nicer, I'll just stick it at the end of this one. So this is 5 steps west, and then what did I have next? 1 step east and 1 step south. So then we had 1 step east, and then 1 step south. Yeah? Okay. Next is the 4 displacement vectors. Okay. So the first displacement vector is this one. The next one is this one. Oops. Because displacement points to where he is. The next one would be there. And the last displacement vector is here. So the displacement points to where he's at as he moves. You understand? Yeah. Okay, so this is part B and C. If you can draw something like this in your book, please. Draw. I'm sure you'd like to draw, yeah? That means yes. Huh? See the question? Sure.
The red color line in the middle.
Yeah, sorry, red was velocity, which is kind of hard to see now, and blue was displacement. Yeah. Oh, go on. What are you thinking? Do you have a question? No, don't be shy. No. Okay. Can I continue?
Yeah.
Okay. I'll let you try the next part. I want to know the magnitude and direction of the final displacement vector. The final one was this last one I drew. So, just to help you a little bit here, I'll just make a grid. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so the man started here, then he went 1, 2, 3, Then he went 5 meters north, 5 meters west, 1 meter east, and finally 1 meter south. So this here, this is the final displacement. So my question is, what is the magnitude, which means the length, and what is the direction? So I'll give you 1 minute to try and write that down. So I'll just write FD for final displacement equals. And there's a little hint in the question as well. Okay. Any answers?
5.65.
That is 1/4 of the answer. No, sorry, that's 1/3 of the answer. Oh no, way off now, way off. You have 2 out of 3 right. You're still missing something. The length, yeah?
I know that. I don't know.
That's okay. What is the length here? 4 root 2.
Yeah.
Yeah. Yeah. You're still missing something though.
The unit?
Yes. That's important too. Yeah. So here This side here is 1, 2, what the heck happened here? I thought it was 4.
The point.
Point.
It is the point.
What?
The second
On the
arrow.
yeah.
This?
No,
It's
it's
down,
not
not from.
your starting point and the next row.
Yeah, I only went 4 across, didn't I? Okay, well let me redraw it. What I was trying to get at the end was this vector here, and this one is 4 units, and this one here 4 units. Okay, now maybe we can answer. So what is the magnitude here? Well, in the question I tell you, if you have a 4 and a 4, this side is 5.65. Okay, so the answer is 5.65 steps per second. But that's not it, because velocity has a direction. So what's the direction here?
Also black.
Yeah, just northwest. Just northwest. Because this must be 45. Yeah, or north 45, west 45 north if you want. Or north 45 west is the same thing, yeah.
We just
Yeah.
say from 45. How about that? Small.
You could say northwest, you could say west 45 degrees north. Degree, yeah. Is this okay? Yeah? So that's the final displacement, what you might call the, that's not per second, sorry. So, he is 5.65 steps northwest of where he started. That's his final displacement. Yeah? Okay, so the last part now is, therefore, what's his velocity? Okay, so we need to use this to get the answer for the velocity vector.
Divided by 9.
Yeah, that's all. So you take this vector, 5.65 steps northwest, and you divide by 9 seconds. Because remember, velocity is displacement over time. So the answer is 5.65 over 9 steps per second northwest. And let's just hit that in on the calculator. 5.65 divided by 9. 0.628 we'll say. Steps per second northwest. Okay. Can I continue? Is this okay? Yeah. Right, next. Now, just a remark about vectors, which I mentioned earlier. If we have two vectors A and B, we say the vector addition is commutative. What that word means, commutative, is that A plus B is equal to B plus A. But I mentioned that earlier. I think it might be useful if you note this word in maths. Commutative means this property, that A plus B equals B plus A. This, in fact, is not always true for everything in maths, but it is true for vectors. Okay, you have this word commutative. Is this a new word for some people? Did you know this word, or is it a new word? Commutative, sorry.
I know community.
Believe it or not, it has nothing to do with communicating. Not similar. And I'm worried if you look it up in the dictionary, you might get a weird definition. Check it. Yeah, you see, I can see from your face. Did you check on the dictionary?
Yeah.
And is the definition clear in the dictionary?
No.
I didn't think so. Yeah, commutative means A plus B equals B plus A.
Ah, thanks.
Okay, good. Okay, did you write that word down, commutative? Yeah. Yeah. Alright, let's have a look now. Right, vector triangle questions now. Yeah, this shouldn't take long as well. Okay, so you can start these ones now. I asked you to draw them, so try to draw them nicely. Yeah.